Hello friends, welcome to my YouTube channel, and in this video we will study about what is actually object-oriented programming. So if you must have heard about object-oriented programming, then you must have you must be knowing that object-oriented programming is consisting of objects and classes, or an object-oriented programmer thinks in terms of objects and classes. So what is exactly an object and what is exactly a class? So a class is an abstraction of a real world entity. It is just a logical construct or a declaration that has no actual physical existence. But an object is an instance of a class. It has actual physical existence and occupies space in memory. So these things will become eventually more clear once we get into designing classes, once we get into making some objects. But still, as an outline, I would just like to give you, so classes are basically, they are used to model real world entities. So any real world entity, it can model, for example, it can model, it can model a speaker. Okay, suppose it can model a speaker, it can model a fan, it can model a radio, or it can model a mobile phone. Any real world entity you give, classes can model these real world entities. So for example, I just want to model an employee. Suppose employee, which is a real world entity, I want to model it using a class. So what will I say? I will design what? I will design a class, and the name of the class will become what? Employee. And then I will just give the structure how the employee will look like. For example, I will say that the employee will have a employee ID, and then suppose the employee will have suppose a name, and then I will say suppose the employee will have some salary. So this way I have designed what this is can be called to be a class. This is what you call to be a class. So class is just, you can see it will not occupy any space in the memory. It is just a declaration. It is declaring how an employee looks like. For example, in my case, employee looks like that. It contains employee ID, it contains name, and then it contains what? It contains the salary. So this is what is actually an employee. It is, I have just created a blueprint of what an employee will look like. But now I can have many employees in my organization. So all these employees will actually exist in the organization, and they will be the objects of this class. Suppose I create suppose there is one object of this class. So there can be multiple objects of this of this class, and each object will have different different ID, name, and salary. For example, there can be one employee like this, whose ID may be 1, whose name may be Amit, and whose suppose name Amit, and whose salary may be 20,000. Or there can be one more employee. Suppose his employee ID can be 2, his name can be Vishal, and suppose his salary will be 5,000. Okay, so these are all what? These are all objects of the class. So class is just a declaration, and then these objects, see, these objects are now occupying memory, because this has now some employee ID, it has some name, and then it has some salary. Then we need some kind of variable to hold all these values. So that is why I say an object of a class always occupies some memory, or an object have actual physical existence. Okay, so I would not go into the very a lot great of details of all this, because we will be eventually covering this once we discuss objects and classes. This is just to give an idea about what is actually object-oriented programming, or what is actually going behind the scenes. Okay, I'll just clear all this, and now move on to the next slide. Suppose I'll just minimize it, and just when we go to the next slide, then there are 4 pillars of object-oriented programming, or object-oriented programming. There are many features that are associated with object-oriented programming, but mainly these 4 features of object-oriented programming are the most prominent and the most the most robust of all. So what are those features? One is abstraction, inheritance, encapsulation, and then polymorphism. So let us cover them one by one. So inheritance, what is inheritance? Inheritance is the process of creating new classes from existing classes. So what does this mean? This means that this is just to basically it is more like intended to stop to prevent code reuse. So many times you need that. For example, you design some generalized classes. I'll just give an idea. Suppose you must be aware of object orientation. You design some generalized classes, and then from those generalized classes you design what? You design specialized classes. So the properties of the generalized class now become inherited in the derived classes. See, these two are my derived classes. So this is what is inheritance. It is mainly used for for code reuse. And then abstraction. So what is abstraction? Abstraction refers to providing only essential information, hiding the background details from the user. So for example, just I take, suppose you must be, nowadays people always use a smartphone. Suppose you have a smartphone, and smartphones has many features. For example, there is one features to call someone. Suppose there is a feature, you can call someone, and then there is a list of suppose contacts, and everything is there in the smartphone. So once you press this this icon, you can make a call to someone, any of the persons. So do you know the exact functionality behind what is happening behind the scenes, how the call is being made to that persons, what are the intrinsic detail, how the circuitry is working, how the signals are propagating to the different mobile phone, and then how all these signals you are able to receive his signals on your phone, and then you are able to communicate. Should you know all these things? You only know how to call that persons. All these all these internal details are being handled by the developers, all the persons who have designed actually this mobile phone. You do not need to know all them. So that is why it is like providing only the essential information to the end user. For example, if you are an end user of a mobile phone, then you just need to know how to make a call. You do not need to know what is the mechanism behind making a call, what is the circuit behind, what are the actual what actually goes behind making a call. You just need to know how to make a call. Similarly, abstraction is a very popular feature in C++. Like, suppose you design a class, suppose a program, and in this program you write many complex line of code, and suppose thousands of lines of complex code, and then you can ship this code to some end user. Suppose you give this code to the end user, and then what, suppose you have designed this class, then some person can do, suppose he can create an object of the class, and then he can use the functionality defined within the class. Okay, so like like that, you designed a complex class, and then you gave that class to some end user, you shipped in that class, and the end user designed the object of the class and then started using the methods of the class. So in this case also, the end user doesn't needs to know what kind of complex logic you have written inside your program, or what kind of what kind of mechanism, what kind of programming is written behind your functions in the class. He doesn't needs to know all this. He just needs to know how to call those functions to perform some kind of functionality. So this is what you call as abstraction. And then what is encapsulation? So encapsulation, encapsulation is more of like derived from the term what is called use a capsule. So you must have seen a capsule, right now, because of the current age, people do not have proper eating habits. So that is why people regularly fall sick, and then they have to take a capsule from a doctor. So anyway, so capsule consists of two things. One thing is that what is inside the capsule. There is some powder or there's some medicine inside the capsule, and then there is an outer cover for the capsule. So can you tell me what is important, the inner medicine or the outer cover? Naturally, the inner medicine is more important, and the outer cover is just present to protect the medicine that is inside the capsule. So similarly, it's a case with classes. So in class, so you have some class boundaries, and in the class you can have some data variables, suppose data 1 and then data 2, all these data members you can have, and then you can have some functions also in the class, suppose function 1 and so on, function 2, like there can be many functions, but all these needs to be protected, since see they are in the class boundary. So this class boundary is acting as a capsule for this data and functions. So now they need to be protected against outside misuse. For example, someone outside the class can create an object of the class and then can access these data members and give them some erroneous values. So we need to protect them. So that is why this is what you call as encapsulation. So generally what we do in encapsulation is that we make these members, if we don't want that they should be accessible from outside the class, we generally make them private. So encapsulation is implemented through the use of accessibility modifiers like public, private, and protected. And polymorphism literally means one interface and many forms. So we will study polymorphism also. Basically polymorphism is of two types. One is the compile time polymorphism and the other is the runtime polymorphism. So compile time polymorphism consists of method overloading and runtime polymorphism is of method overriding. So I would not like to explain polymorphism in great details right now because you will not be able to understand it. Polymorphism becomes more clear when you actually see a running example of seeing how polymorphism is implemented. But still, as far as runtime polymorphism is concerned, then one function call can refer to different functions depending upon the type of object that it points to. Or in the case of compile time polymorphism, the functions have the same name but different argument list. So depending upon the number and the type of arguments, different calls to different functions are made. So this is what you call as polymorphism. So these are the 4 pillars of object-oriented programming mechanism. Like it is said that sinful life is comprised of 4 pillars also. So on these 4 pillars object-oriented programming stands. And if you talk about sinful life means a life that is not very pious. And a sinful life stands on 4 pillars. And what are those four pillars? Those 4 pillars are intoxication and illicit relation with opposite gender, and then it is gambling, and then it is meat eating. So these are all I'll just write it down so that it is just out of the context of the video, but I would write it down. If someone is a meat eater, someone is intoxicating, taking wine and all this, intoxication, and then one is illicit relations, and then the fourth one is gambling. So these are the 4 pillars of sinful life. Like these are the 4 pillars of object-oriented programming. These are the 4 pillars of sinful life. So if a person regularly indulges in these activities, then it is very sinful. So we should although it is very difficult to avoid them and to live without them, but still we should, to whatever capacity we have, we should try to avoid them. Okay, sorry if I said if I've hurt your some kind of sentiments, but I just wanted to convey the message. Thank you so much for watching my videos. Please do keep on watching all my videos.